Welcome back, guys. We are going to take a minute to talk about operations on complex numbers and imaginary numbers. And so before we get started, we are going to just take a minute to look at what it means to be an imaginary number, what it means to be a real number, and how those two come together to form what's called a complex number. Okay, so first of all, we need to have an understanding of the fact that we're using the letter I, a lowercase I, to represent the square root of a -1. And so we're going to be working a lot with this imaginary value, and we're going to be doing some work with simplifying. And in our last video we had a quadratic that had the square root of a -9, and we saw that that simplified to 3 times I because we separated it into the square root of 9 times the square root of -1, and in that way we're able to arrive at a result of 3i. And you can do this with, different negative roots as well, and simplifying them here. You see the square root of 121 is your 11, and the square root of 49 is 7, and of course the square root of -1 we're just leaving as your imaginary number I. So a lot of times you will see the imaginary part of the number not just as the value of I, but something like 4i or some other type of fraction, 1/2 I. Okay, so you know that that is the imaginary part of your number. Okay, so when a real number like 3 is combined with an imaginary number like 7i, the result is called a complex number. Okay, so complex numbers will always be of the form a plus bi, where the real number portion comes first and the imaginary portion of your complex number would be written second. All right, and as we perform operations on complex numbers, what you're going to notice is that we are going to be treating I, the letter I, just like the variable it is. Okay, and same rules apply. We have to combine like terms. We might have to multiply things. One unusual thing that happens when we are working with imaginary numbers, however, is if we ever get to that point where we're actually squaring I, remember that is going to be the same as the square root of -1 times itself, and in that case we actually get the real integer -1. So we know that I is equal to the square root of -1. I squared is actually equal to -1. This is going to be an important piece to keep in mind as we go through these next examples. Okay, so let's just cruise through a few examples here of working with complex numbers, and this should help you with your assignment this week. All right, here we go. So same orders of operation apply. In this case, I'm going to be multiplying, and I get I times I, which is I squared, plus, and I'm going to distribute. Same idea here, distributive property, so I get a -14, and it looks like -49i. And one of the things as you continue to simplify that you want to remember is that this I squared, what is I squared? equal to? That's right, it's equal to a negative 1. So this negative 1 times my negative 56 becomes a positive 56 minus 14. Okay, I'm getting updates. Don't need to know about that right now. Minus 49i. So it looks like my result here is going to be what? 42 minus 49i. And that is my complex number that is the solution to my problem there. Okay. Here's another example with some multiplying, and I'm going to just go ahead and multiply these first and then distribute. So we have 2 times 6, of course, is 12. I times I is I squared, which means it looks like as we continue to do this problem, number 1, I might have to get out my calculator, and number 2, this I squared becomes a negative 1. So this is actually going to be a negative 12 times a negative 5 minus 5i. So as we multiply and distribute this through, it looks like our final answer here is going to be a positive, is that right? 60 plus 60i. Okay. So that's how that one rolls out. Pretty easy so far. Just dealing with that I just like you would any normal variable, except for the situation where you have to simplify a little bit further if you have an I squared. Let's try this one. Well, for this one, since we're subtracting, I'm going to multiply through by a negative 1 first and then combine like terms. So it's going to be 4 plus 2i. And then it looks like it's going to be a plus 1 and plus 6i, and then I am just going to combine like terms. So I notice here that my like terms 4 and 1 can be combined, and then also my 2i and 6i can be combined for a 5 plus 8i answer for that particular type of problem. Just combining like terms, distributing that negative 1 first. Okay, so all of that is pretty straightforward. This is where it can get a little bit crazy. And this is where we are once again going to think about what is called the complex conjugate. Okay. So remember when we use the conjugate to simplify square roots? Well, we're going to do the same thing anytime you're dividing by a complex number. So the process for dividing by this complex number, which is negative 7 minus 4i, is going to be to multiply both the top and the bottom by, you guessed it, you're going to take the opposite of the imaginary number here, plus 4i. And negative 7 plus 4i. Now again, as we do this, the reason for that is to get rid of, we're gonna actually end up with a new complex number, but there's going to be no complex value in the denominator. And that's what we're shooting for when we do this division process. Okay, so this is a special type of dividing complex numbers problem. Okay, so watch out for this kind. All right, so let's cruise through this real quick here. It looks like we're going to have a negative 56i plus 32i squared. And remember, we're going to be doing something special with that I squared here in just a minute. In the denominator, negative 7 times negative 7 is my positive 49. And here's where I'm getting my minus 28i and my plus 28i that are going to cancel as I'm multiplying these two binomials together. And then my negative 4i times my positive 4i is going to be a negative 16i squared. But don't forget, That little I squared is going to be, we're going to get a little special attention to that. Okay. So in the next step, let's go ahead and give our special attention to our I squared and change it to a -1, and we'll see how that, how things turn out. Okay, so I'm going to do this one first. I squared is -1. -1 times 32 is going to be, whoops, come back. I don't need that. Oh, we need this. Okay, here we go. We're still going, still rolling. It's going to be -32 and then minus 56i. Okay, that is our numerator. In our denominator, we're going to notice that these middle two terms are going to cancel. And I'm going to have 49 and then a negative, here it is again, my -16 times my -1. It's going to be plus 16, so we're just going to keep rolling with this. -32 minus 56i, all divided by, what's that going to be, 5065? And we could see if this simplified a little bit. I'm not quite sure that it will, but the real part of our complex number is -32/65. And then the imaginary part is my minus 56/65i. Right? We're breaking that into two separate fractions so we can reduce if possible. And that is our complex number. All right, guys. Hopefully that was a good little example of how you can work through some complex number problems. Good luck with your assignments this week, and I'll see you in class.